Okay, everyone, so let's welcome our next speaker. We have Felipe Erias from Igalia, who will talk about and show us the Wolvic browser for VR and extended reality. Welcome, Felipe.
Hello, thank you. Thank you very much for coming to this talk, where we are going to be talking about web browsing in extended reality. And in particular, we're going to be looking at the Wolvic web browser. So just as a small presentation, my name is Felipe. I work for Igalia. Igalia is a free software consultancy, and we are specialized in open source technologies on a wide variety of platforms. We mainly work with the web platform, but we also do works in graphics, kernel, and many other things. So in this talk, we are going to be talking about the challenges and the opportunities of web browsing on extended reality devices, drawing from our experience at Igalia in creating the Wolvic browser. Web browsing on extended reality enables users to navigate and to interact with traditional web-based content and also with immersive experiences that can only really be enjoyed with special virtual reality devices. And in order to do this, Wolvic is an open source web browser for extended reality devices that is able to display these traditional and these immersive experiences. And currently, it is the only multi-platform web browser for extended reality. So let's start by having a look at the traditional web, what we think of traditional web browsing. So usually this is something that we experience in our desktop PCs, our smartphones, and we think of concepts like windows and tabs and navigation, following links, going back and forward, also keeping track of your bookmarks, the history, the download, managing passwords, extensions, and this is all functionality that people expect of a web browser, whether it is a traditional one in a desktop or a phone, or a web browser for extended reality. So this is something that we need to provide because it's how people expect to be able to use the web. And some of this is already provided by the web engine that interprets the web platform standards, and some of it needs to be implemented specifically for XR. So this is how the Wolvic main user interface looks by default, where we have this browser window with some functionality specific to that particular website, and then some more generic functionality in a tray bar at the bottom. And this is something that you can use in with extended reality device that you can use to browse the web. And we also need to implement special ways to access functionality that people expect, like for example, searching the text in a website. This is another example of the kind of functionality that people expect, and then we also need to re-implement and adapt for extended reality. And there are many APIs in the platform that we need to account for. For example, this is a date picker where we need to implement a special dialog that appears in the 3D space that lets you pick a date, or a file picker that shows you the file in your computer, in your device, so you can upload them. Or, for example, we can also interact with the web app API and get some information about a website and get additional capabilities, additional high definition icons, and so on. And we can integrate that in our user interface. A big difference between a traditional web and extended reality devices is in the sense of input methods. Typically, extended reality devices use controllers, they use hand gestures, and other methods are supported by some devices. But most of the web has actually been made with desktop computers and with smartphones and touchscreens in mind. So this means that there's a mismatch between the input methods that the websites usually expect and the input methods that the platform, the devices, provide. So usually at Wolvic, we solve this issue by pretending to be a phone from the point of view of the website, or sometimes we need to pretend to be a desktop. But sometimes this mismatch can be noticeable. This is a challenge because the websites may use input modes that cannot be easily replicated in extended reality. Like they can use multi-touch gestures, they can use keyboard shortcuts, and this can be a challenge. One of the ways to get around this is by extending the range of input methods that we support. So for example, in Wolvic, we are working to add support for external keyboards, voice input, and others. This is, for example, our support for hand tracking, where we recognize the hand using an API, a capability that is provided by the platform, the VR platform. And then we apply a 3D model to that information, and then we recognize different gestures, like pinching, for example, so you can scroll the website just using your hands. Another important challenge for web browsing in extended reality is readability, is the ability to read documents, because reading documents is one of the most basic ways of using the web. It has been traditionally the main purpose of the web, and the reason why it got started was to share and to read documents. And that is something that we need to support in extended reality. But one limitation that we have is the resolution of the screens in the headset, which means that in order to have text that can be readable, we need to manage a trade-off between making the screen larger, but it cannot be too large because otherwise it covers your whole field of view, and making the text itself larger, but then if it's too large, then it messes up the layout of the website, and it also becomes harder to read. So this is something that we have to manage, but the situation has been improving as the hardware gets better, resolution gets better, and then we are able to make it easier for users to read documents in extended reality. So this is an example of a page in Wikipedia where we can increase the size of the window to make it twice as big, but then in this case, the layout of the window makes it easier to read, but in a virtual reality device, this large window is already taking almost all of your field of view. So it's like you have a huge window floating in front of you. So that's a trade-off that we always need to keep in mind. Having said that, the fact that in extended reality you have this large virtual space provides great flexibility to the user interface, and this can be a great opportunity for productivity applications because we can arrange the content around the user in a way that makes the most out of spatial thinking and spatial memory, and the fact that we are very good at reasoning if we know where things are in space. You remember that you put something here and you put it to the side. It's not in front of you, it's not getting in the way of the task that you are doing, but you're sort of aware that it's in the periphery. And I think that's very powerful. And it's also a way that people organize their physical workspaces. If you look at somebody's desk, the person may have a document that they are working on at the moment, but they have other documents that are around, that may have stacks, they may have them organized, and it's like a whole environment of information that is all around them. And because it's stable, it has a physical presence, it becomes far easier to remember. And I think that's an advantage that immersive virtual reality has, and something where I think productivity for information workers can be greatly improved. So I have a few examples. In this case, for example, you can have two windows side by side in your space. You can be looking at a painting, and you can also be looking at the YouTube channel of the museum. It's another example where you can be looking at a wiki page, you can be looking at YouTube, you can be looking at the museum's website, and they are, the three of them, all around you, covering your space. So you can move from one to the other just by moving your head. Currently in Wolvic, we are able to show up to 3 windows around the user. And we are working to implement a more flexible window management system. So we want to be able to show many windows and give the user great flexibility to position them in space in a way that matches the way that they want to work. So eventually we want to be able to support complex user interface or a rich user interface, if that's what you want, with many windows, with tabs and shortcuts, if that's what you want. But on the other hand, we also want to be able to support very simple, very focused user interfaces for other use cases. So we have to cover that range of complexity in the user interface, for something very simple to something very complex, and make that transition easy so people can adapt the application to their specific needs. Another important kind of content that people use in the web is video. And this is usually provided as regular 2D video, but there's also 3D side-by-side stereoscopic video that I will show in a moment. And this is something that as a web browser we also need to be able to support in extended reality. This covers platforms such as YouTube and other video websites. And it also covers video services like Disney Plus and many, many others that provide subscription services and provide video that is protected by DRM, by digital rights management systems, which needs to be decoded specifically so that the people can watch them. So this is an example from Disney Plus of a Wolf documentary. And notice how in this case we have updated the user interface, we have dimmed the environment, we have hidden all the buttons so you can focus on the video. So this kind of flexibility is something that immersive applications make very easy and very powerful. The ability to change the whole environment around the user to focus on the specific task at hand. This is another example also from Disney Plus. Again, notice how we have updated the whole user interface, the whole environment to focus on the video being played. This is a small example from YouTube and what the functionality that is interesting here. Maybe not sure if you can see it. We implemented support for captions in YouTube. So as the people are talking, what they are saying is being shown on top of the video, which is a functionality that YouTube provides and that we support as well. And this is the other kind of video that I mentioned, the side-by-side stereoscopic video, which can be seen in video in movies like Avatar. And this is served in YouTube as a regular video file. And then we are able to show that as two separate videos, one for each eye, and that gives you the impression of the characters coming out of the screen. Which leads us to our next topic. So we have seen how the traditional web looks like in extended reality, and now we're going to look at the immersive web, the kind of web content that can only really be properly experienced in extended reality devices. First one, as I mentioned, is video, which is usually served just as a regular video file. And what makes it special is that the video has an additional metadata so that the extended reality browser knows how to display the video according to a specific geometry. And it makes it possible to have the kind of 3D side-by-side video that I just showed, but also makes it possible to have immersive videos. And there's lots of this on the internet. Videos of traveling, videos of flying, and this is a really great way of experiencing this content. And it's an experience that you don't really get if you're just seeing this on a small screen in front of you. You don't really get the experience of flying among the mountains and looking around. A lot of this is travel videos. There's also some more dramatic stories, and I think it's a new medium that is going to keep evolving and where people are going to continue experimenting and finding new ways of communicating and telling stories. The next point in the immersive web are immersive experiences, interactive applications. And for this, the main standard is called WebXR, which is a collection of web APIs that allow people to create immersive experiences on the web. In our case, in Wolvic, WebXR is mostly implemented by the web engine, I will mention in a moment, but we still need to connect it to the graphical layers, to the input methods, and all that. As a first example of an application, we have this simulator of painting with graffiti, and then I can show a more complex painting simulation where that simulates painting with actual paint that blends and mixes. And then the third example, and this is interesting because it's simulating a real physical experience. What's powerful about immersive applications is that you can imagine other kinds of experience that don't have a physical equivalent. This one, for example, is painting with light in 3D space. And you don't really have a physical model for this. It's not trying to simulate a real thing. It's a new medium that is only possible with this kind of immersive devices and experiences. So I think there's a lot of experimentation, a lot of creativity that is being unleashed in this space. One of the main applications and one of the main opportunities for immersive content on the web is education. Because there are many kinds of information that you can really only understand if you are able to immerse yourself in it. If you are able to have a sort of embodied experience where you feel like you are in a specific place, you get a far more intense understanding rather than if it's something that you just read about or just look at it on a small screen. And furthermore, the web makes it very easy to distribute this educational content because there's no need to create a separate app or to have to deal with different app stores and so on. And you can even use existing platforms like I mentioned, for example, YouTube for distributing immersive videos. So I think for education, it's a big opportunity, and also the fact that it can be distributed over the web makes it much easier. So I have a few examples here. This is 360 video taken off an airplane, and it's taken from the point of view of the pilot. So you can look around the cabin, you can see what the pilot is seeing, you can check how the pilot is using the controls, checking the different measures, speaking on the radio. You can have the whole experience of a complete flight. But this is not interactive. This other example is an interactive video for flight attendants where there are different events happening during the flight, and then the point of this application is for the attendants to identify whether there might be a problem, there might be a passenger that is having issues. And again, this is something that becomes a very rich, powerful way of doing this training. This is an art gallery, and there are immersive spaces that can. So you are able to visit the actual physical art gallery in virtual reality and walk through the corridors and look at the paintings. And this is an actual real museum. In this other example, this is a virtual museum, a museum that doesn't exist in real life, that has been only constructed for this particular collection of paintings that might not all be in the same place. And this allows a lot of creativity also with the kind of experiences that you offer people. In this case, for example, there's a recreation of a painting, and you can step inside the painting and have a feeling for how that environment would have looked like at the moment when the painting was made. And I think this idea of stepping into the content, stepping into what you are studying is very powerful. This is the final example. This is a web application by NASA where they use real data and satellite photographs from Mars to reconstruct an immersive experience of being on Mars and looking around and just seeing how unlikely it is that there's a robot up there in that immense space, which is something that, again, you don't really get unless you are able to feel like you are there and you are looking around at things. Another very popular use case for XR is gaming. And gaming in XR has some challenges. One of them, for example, is that might need to deliver large assets to users. So there might be an issue with users having to download content before playing the game. But on the other hand, since the game is online, it can also mean that the assets can be streamed. You don't need to download the whole game to be able to play only the first level. There might be some issues with performance, although with the newer WebXR platforms, they are approaching really good performance because they have been optimized for this particular use case. And again, one advantage that the web as a medium has is that makes it very easy to get started and to distribute your creations to a lot of people. So this has created a large community of independent developers just trying things out and sharing them and seeing what works. So I have a few examples. One of them is this one where you manipulate blocks in space to solve a puzzle. There's another one, there's a simulator of rock climbing where you have to look around and find where the next grip is. There's a really fun one where you wave your lightsabers in space as the music plays. And it has really good performance. It's a really fun game. And again, it's a web application. This is just running on the browser with really good performance. And now I'm going to talk a bit about the Wolvic project. Wolvic is the browser that has been used to run all the previous examples of web content that I showed. And it's a browser that we are developing at Igalia. And it is the multi-platform web browser for XR devices. It started as Firefox Reality, released back in 2018 as part of a mixed reality initiative at Mozilla. And the project was eventually handed over to Igalia in 2022. We changed the name and we continued the development, and we continued adding new functionality and porting Wolvic to be able to run on more and more devices. So this is what we have been doing until this day. In terms of technical components, Wolvic has a small 3D library that allows us to position elements in the 3D space. It uses a web engine to be able to render the websites I will mention in a moment. Much of the rest of the user interface is composed of regular Android UI components. And in order to provide some browser functionality like bookmarks, downloads history, and so on, we use some of the components that are used by Firefox on Android. To access specific capabilities for the XR devices, we use mainly OpenXR, and then in some very particular cases, we might use some platform-specific libraries. So I mentioned web engines. A web engine is the component that interprets and renders and knows how to paint a website, so to speak. Currently, our main one is Gecko, which is the same one that is used by Mozilla Firefox. We're using the standalone Android library that Gecko provides, but we are also working to be able to support multiple web engines. And the next one coming up is Chromium, which is the one used by Google Chrome, and we are currently under heavy development. As I mentioned before, Wolvic is a multi-platform application that is able to run on a wide variety of XR devices. And we're able to do this by relying on OpenXR, which is an abstraction layer that allows us to access XR functionality. We still do need to take into account each individual device. We need to take into account that the devices might have different capabilities, they might have different bugs even. So we need to test and adapt Wolvic for each specific device. Also because the devices themselves have different formats. There are large headsets, there are augmented reality, they are devices that you connect to your phone. So each one have their own very particular user experience demands. So we need to adapt Wolvic so it can run well and it can be useful on each device. Wolvic, as I mentioned before, is an open source project. Is released under an open license. And we use GitHub for development, for the code, for the issues. We keep a wiki there also for developers. It's currently being distributed in several app stores and Huawei, Meta, and Pico. And we also provide packages for site loading that people can download and install on their devices directly. And Wolvic is funded through an open collective where partners can contribute to the project. So this is our GitHub page where we have the code. We also have instructions for building Wolvic and for getting the different components of the application. We have issues and we have a wiki for developers, and basically it's a good starting point if you want to contribute with the project, if you just want to try things out, if you find an issue, if you find especially if you find a use case that we maybe might not have thought about, but that you feel is important, the GitHub page is a good place to get in touch with us and get us to support you. This is the Wolvic page where we provide packages for site loading for a bunch of different platforms so that people can just download and install them directly on their devices without having to go through an app store, although we do support some app stores, as I mentioned. And this is the Open Collective website. So as a sort of conclusion, I think my main points in this talk was first that web browsing on extended reality has a huge potential for many use cases that go from education and productivity to entertainment and games. Distributing this content through the web makes it much easier to experiment and to make sure that these experiences reach users. And this fosters creative communities that can share and iterate on their ideas very quickly and very creatively. There are still some open questions in terms of the design of the user interface, the input, interoperability between platforms and so on, but those are questions that are being solved step by step. And in this field, Wolvic is a key player as the open source and multi-platform web browser for extended reality. Thank you very much. And if you have any questions or if you want to come talk to me later.
Thank you, Felipe. Let's see if we have any questions from anyone in the room here. All right. Thank you.
Thank you so much.
Thanks.